Hi, remember me? Well, if you do, I guess you know what we're gonna talk about. So, let me ask you this. Have you ever felt like you're getting pulled out of the car when a car gets through a curb? Or did you think there's any kind of a magical, invisible force that's keeping all of the objects still? Well, if you did, you're not alone, my friend, nor are you first that think about it. And today we're gonna talk about all of those misconceptions of motion and forces. Okay, so let's start with the idea of inertia. A lot of people, as I said, are thinking about this force that is keeping things at place. But as a matter of fact, that's not entirely true. And it's not that nothing is keeping us still, but in fact, there's nothing that actually is pushing us. Inertia is an object's natural resistance to change. So if something is at peace, it will stay like that until other force is acting on it. But Noah, what if that object is already moving? Well, you will just leave that object moving. And notice that this object did not slow down because we lost inertia, but because of friction, which is a force that is constantly slowing us down. This is why when a car suddenly stops, your body will keep on moving if you're not wearing a seatbelt. This is inertia in action. Now, here's an interesting one. Centrifugal force. You know that feeling that you get when you're spinning in circles on a carousel or even on an office chair? Like there's a force pushing you outward? Yeah, that's not a real force. What is really happening is that your body just wants to keep on in a straight line. And yep, there's that inertia thing again. There's always something, such as car seat belt or seat on a carousel or even this chair that I'm currently spinning in, that forces you to change direction and follow the motion of a curve. That's what we call a centripetal force, doing exactly the opposite and pulling you inward. You only feel like you're being pushed outward because your body is resisting the turn. But technically, nothing is pushing you out. You're just being held in by other things. And next up is mass versus weight. People usually tend to mix these up, but this is really important to us physicists, so let's break it down.
That's one small step for man, one giant leap for mankind.
So what is what? Mass is basically how much stuff are you made up of, or rather, how much matter do you have in your body. And that thing does not change, whether you are on Earth or on the moon or floating in space. The only way to change that is to either add some matter or subtract some matter. But weight is a bit different. It's about how hard the gravity is pulling you to press on some surface while you're standing on it or sitting on it. So on the moon, you're gonna weigh less, but not because you're gonna have less amount of matter. You're gonna use the same body, hopefully, but because the gravity is gonna be weaker. I know that all of that was short and sweet, but what did we actually learn? First, we learned that inertia isn't a force, it's a natural tendency. Then, we learned that centrifugal force isn't the force that actually exists, but it's rather inertia being disguised. And finally, mass and weight, two totally different things. So, when you understand how motions and forces work, your everyday life is going to have a completely new view, from riding in a car all the way to being an astronaut in space. You know that physics can explain it all.